Oak savanna was once widespread throughout central North America and Minnesota, where it was located along the border between the prairie and the more mesic deciduous forest biomes. However, because of land clearing and fire suppression, less than 0.1% of the original oak savanna remains in Minnesota. Cedar Creek contains about half of the remaining high-quality oak savanna. Oak savannas have high conservation value because they are habitat for animal and plant species, including red-headed woodpeckers, which are in decline elsewhere. In 1964, the very first experiment was established at Cedar Creek to study the effects of fire frequency on savanna ecosystems and help maintain open savannas and woodlands. This experiment remains a major focus of the LTER. The experiment now includes about 25 units ranging from 2.5 to 30 hectares that burned at different frequencies, ranging from never burned to burned almost every year. LTER research has documented marked effects of fire on vegetation composition, vegetation structure, and ecosystem processes. In the absence of fire, the canopy closes and the ecosystem becomes oak forest, with other common trees like maples, elms, and pines slowly recruiting. Frequent fires convert forest to open savanna with scattered pin and bur oaks in a matrix of tallgrass prairie. At intermediate fire frequencies, shrubs such as corylus or hazel persist and outcompete the prairie species. Plant communities across the fire frequency gradient include nearly 300 species, many adapted to fire and high light conditions. LTER research has shown that fire also dramatically alters ecosystem processes. Chronic frequent fires lead to large losses of nitrogen, and net nitrogen mineralization rates are tenfold lower in frequently burned savannas than in unburned oak forest. Low soil nitrogen cycling is reinforced by the dominant C4 grasses, which decompose slowly and tie up more nitrogen as they break down compared to oak leaf litter. As a result, productivity is nearly 3 times higher in unburned oak forest than in oak savanna. Fire-driven declines in productivity in turn lead to declines in organic matter inputs to soils and thus to lower soil carbon stocks in the most frequently burned plots. The plant communities along the fire frequency gradient are currently in transition. In recent years, oak wilt, a novel fungal pathogen that causes high mortality in pin oaks, has taken hold in the savanna and oak forests. Once established, the fungus rapidly spreads below ground between adjacent root systems, killing the pin oaks, especially where tree density is highest. Frequent fire and disease have implications for the persistence and composition of oak savanna in the coming decades. Frequent fires are needed to prevent shrubs from overtaking prairie vegetation in the oak savanna openings. However, frequent fires also prevent oak seedlings and saplings from recruiting into the larger size classes that can resist fire. Thus, the frequent fires that are needed to prevent woody encroachment may eventually lead to the long-term conversion of oak savanna to prairie grassland. Given the high conservation value of oak savannas, research to explore management strategies that can promote oak recruitment while preventing encroachment by shrubs is needed.